Slope-intercept form of a line. So we've already talked about standard form of a line, which it mentions here in your book at the top of the page. AX plus BY equals C. We are now going to talk about a new form of a line, which is called slope-intercept. This is actually the most common form of a line. This is the form you're going to see on almost any standardized test. You're going to see slope-intercept form. All right, and so slope-intercept form you're going to see over and over and over again here. You're going to see it in geometry. You're going to see it in Algebra 2. You're going to see it if you take calculus with me. You will see this equation of the line. Like, it never, ever goes away. It's the most common equation of a line. So on your handout, we have some things we're going to fill out to help us remember what all of these things stand for. First of all, the slope-intercept form of the line is written in the form y equals mx plus b. So that's what's in the middle of this page here. A couple things to remind you of. The slope is the rate of change. It is rise over run, which we talked about. The y-intercept is where it crosses the y-axis. We also talked about that. So rate of change, that's rise over run. That's your slope. Y-intercept, that is where it crosses the y-axis. So those are vitally important things that help you graph a line. The formula for the equation of the slope of a line using its slope and its y-intercept. This is what the slope-intercept is. So where the standard form just puts your x and y on the same side with a constant, the slope-intercept form is actually written where it's an equation of the line that uses the slope and the y-intercept specifically. And so in this y equals mx plus b, the m represents your slope. The m represents your slope, and the b represents your y-intercept. This is why when I got the questions that matter what order it's in, this is why you want to write it with the x first, because of this equation of the line, y equals mx plus b. All right, your x and your y remain variables. So when you write this equation, your m should be filled in with a number. Your y-intercept, your b, should be filled in with a number, and your x and y should remain variables. They should stay there. You should have an x and a y in your equation, unless you have a special case line like y equals a number, and your m is a slope is a 0, and so then you won't see your x. We're going to do special cases too, right? So this is your slope-intercept. So we kind of hinted at this when we had the standard form and it said solve for y. That's what it was doing. It was actually putting it in slope-intercept form. We just had not named it yet. All right, so slope-intercept has the y all by itself. Now, when it is in standard form, does not mean that the number in front of your x is your slope. That's not what it means in standard form. It only means that when you have it in slope-intercept form. So the number in front of your x only represents the slope when it is in slope-intercept form. Okay, the constant only represents the y-intercept when it is in slope-intercept form. All right. So let's look at this example from your book. Example 1 says, write 3x plus 2y equals 6 in slope-intercept form, then state the slope and state the y-intercept. So the first thing we're going to do is we're going to take this and we're going to put it in slope-intercept form. To do that, we need that y all by itself. All right. So the first thing we're going to do is we're going to move that 3x over to the other side. Remember, when you move it over to the other side, you change the sign. So it was a positive 3x here. It's going to become a negative 3x over here. That's the only way to cancel it out. So now on the left-hand side, I have 2y. Because I'm putting it in slope-intercept form, I'm going to list that x first. So I'm going to say negative 3x, and that's a positive 6. So negative 3x plus 6. All right, my y is still not by itself. What do I need to do to get the y completely by itself? I need to divide by 2, and I need to divide everything by 2. Okay, so I have to divide this by 2, this by 2, and that by 2. Everything has to be divided by 2. So on the left-hand side, it does cancel out, and I now have the y completely by itself. On the right-hand side, negative 3 over 2 cannot reduce. If it could, I would reduce it. It cannot. So I'm going to leave that as a negative 3 halves times my x plus 6 over 2 does reduce. It is 3. Okay. This is in the form y equals mx plus b. Y equals mx plus b. So now it's asking for my slope. My slope is the number in front of my x. So if it's asking for slope, then my slope is -3/2. My y-intercept, that is the b of this equation. So it's also asking me for the y-intercept, which is going to be +3. And if you do it so if it asks like that and you write it like that, that's fine. If it wants a point, it's always going to be where your x is 0. So your point is 0,3. All right, your point is 0,3. But as long as you list it like that, it's fine. You don't have to put the 0,3 there. Just know that it is on the y-axis when you graph it. So when we start to graph it, it is the point 0,3 that you're graphing. So if you look below that, it gives you some tips to changing a linear equation to slope-intercept form. Solve the linear equation for y. Arrange terms on the right side with the x variable first. So solve for y. Make sure on the right-hand side you have your x listed first. All right. So let's try a couple of these. State the slope and y-intercept of the linear equation, and then write it in slope-intercept form and state the slope and y-intercept of the equation. How does this help us graph? Well, I have a point because I have my y-intercept, and I have my slope because it's in slope-intercept form, and I have the m. And so to graph, I can start at my y-intercept, like I started at a point on the other ones for homework, and I can move according to my slope. I mean, it's the easiest way to graph when it's in slope-intercept form for sure. You do want to be careful about your positive and negative movements with your slopes, because it's an easy, quick way to say, did I do this correctly? The other thing that I see people do all the time is they put their y-intercept on the x-axis. You're not supposed to. The y-intercept goes on the y-axis. And so you always start on the y-axis when it's in slope-intercept form. All right, so they want us to graph this particular line here. Y equals -3x plus 2. And so I am going to start on my y-intercept. Well, what is my y-intercept of -3x plus 2? Yeah, it's +2. So I'm going to start at +2 right there on the y-axis. -3 slope. Well, that's the same thing as -3/1, which means I can go up 3 and left 1, or down 3 and right 1, as long as one of my movements is negative, right? As long as one of my movements is negative. And then to graph this, I am just going to connect my dots, all right? You do not have to do 2 points. You don't have to go up and down. It does help you maybe think about what you did and did you graph it correctly? Because they should fall on that line if you did it correctly. But you don't have to do 3 points. You can just do the y-intercept and one movement from your slope. And so once you get it in slope-intercept form, you look at your y-intercept. That is always on the y-axis. That's So once I start here, negative 2/3, all right, I can go down 2 and right 3. That's one negative movement. Or I can go up 2, that's positive, and left 3, one negative movement, okay? But either way, my line should be going up or down. Down, right? My slope is negative 2/3. So negative 2/3 going through a negative 1 there. Should look like that. You can use the graph to write the equation then in slope-intercept form. So I can say, well, my equation is going to be y equals, what's my slope? Is my slope going to be positive or negative for this first one? Negative, right? I go down 1, 2, and over 1, 2, 3, 4, 5, 6. So down 2, that's negative 2. Right 6. How does that reduce? Well, negative 1/3. That is my slope. So I know my slope is negative 1/3. That's my mx. And then my b. My b is where it crosses the y-axis. Well, it crosses the y-axis right here. What number is that? Negative 1. So I'm going to finish this equation with a -1. That's my slope-intercept form of that particular line. Y equals negative 1/3 x minus 1. So then how would I do this other one? Is this slope positive or negative? Positive. So I know I'm going to have a positive slope. I go up 1, 2, 3, 4, 5, 6, and to the right 1. 6 over 1. My slope here is just 6. And then my y-intercept. My y-intercept is down here. What number does this represent on the y-axis? Negative 3. So 6x minus 3. Right? Easy enough. Really quickly, I want to show you this. We talked about special case lines. Y equals 3. Remember, that's a horizontal line at 3. What is my slope of a horizontal line? So it makes sense why this equation doesn't have an x in it, right? Because my y equals mx plus b is going to look like that. And it's kind of strange to list 0 times x, so you just write it y equals 3. All right, and so that's why that one looks that way, because it is technically in slope-intercept form. So if you have a 0 slope, this is what your line is going to look like, just y equals a number. What is my y-intercept on this one? Plus what? What am I adding to it? 0. So I start at the origin. If it doesn't show a plus anything, it's just plus 0. So I'm actually going to start one like that right here, because that is my y-intercept, the origin. And then there are going to be times when you might have to do more work to put it in slope-intercept form. Here I would have to subtract a 5 and divide by 3, all right, to put it in slope-intercept form. So they could give you something that has a 0 as a y-intercept, a 0 as a slope, or you have to solve to get it into slope-intercept form. All right. Put it in slope-intercept form and